Alright, unit 5.4, which is still systems of equations elimination method, but it's a whole separate part, because what if it doesn't have a common coefficient to cancel, right? And so what should we do? And this is going to tell us what to do. Alright, so if there are no common coefficients, multiply one or both equations by some number to create matching opposites, to create matching opposite coefficients. Right? Because we're doing it to the whole equation, it's not changing the value of the equation, it's just creating an equivalent equation. And so if we have to do it to both of them, that's fine, as long as we do the same thing, right? So, for example, on the first one, let me see if I can make it a little bit bigger. Pause it if you want to write this down, because it's about to disappear. So I can make it bigger. Alright. The internet's down, so I'm doing this without Cami, which means I can't annotate directly onto the document. Work with me, alright? Remember, we're on 5.4, part 2. Right? Part 2 of elimination method. Alright, so there's not a common coefficient. So I could either multiply this top one by -2 so that they would have a common coefficient, or I could multiply them both by each other, right? So they would have a common coefficient, right? So if I wanted to make the coefficient for y the same, 21 would be the common multiple, right? So I could multiply this by 7 to make this 21, and I could multiply this by 3 to make this -21. Whatever's the easiest one to cancel is what you want to multiply by. In this case, making this -2 is definitely going to be the easiest, right? So if I multiply this by -2, then I end up with -2x minus 6y equals, make sure you distribute it to everything, right? It doesn't stay the same. It's not equivalent unless you distribute it to everything. So multiply everything by -2. Right? So that would be -12. Now they have a common coefficient. 2x minus 2x is 0. -7y minus 6y is -13y. And -1 minus 12 is -13. So divide by -13 to isolate the y. So your y is going to equal +1. You can put that into any equation. You should get the same answer. Let's find out. We're going to put it into all 3 equations. The original 2 equations and the equation we created. Let's see what happens. Alright, so x plus 3 times 1 equals 6. We end up with x plus 3 equals 6. Subtract 3 from both sides. X equals 3. Let's see if we get x equals 3 on all of them. Alright, 2x minus 7 times 1 equals -1. 2x minus 7 equals -1. Add 7 to both sides. 2x equals 6. 2, 2, x equals 3. Oh, that's interesting. One more. The new one we created. -2x minus 6 times 1 equals -12. -2x minus 6 equals -12. Add 6 to both sides. Negative 2x equals negative 6. Divide both sides by negative 2. X equals 3. Either way you go, you can plug your y, you can substitute your y into any three equation, any one of the three, and you'll get x equals 3. So our solution to this system of equations, our x value is 3, our y value is 1. That's our solution. And if you're listening and not just copying, you'll know that you don't have to do all three of these. You only have to pick one. Whichever equation you think would be the easiest to solve, which honestly I think was the first one. But you'll have to take practice and figure that out as you go. Pause it if you need it. I'm about to erase it. Alright, number 3. Alright, common coefficient. It already has a negative and a positive y, so I'm going to use that. You could make one of these positive 15 and one of them negative 15. That's your choice. But I'm going to use 4 to make this a negative 4y. So now we have 12x minus 4y equals, what's 14 times 4? 4 times 10 is 40, 4 times 4 is 16, 40, and 16 is 56. I know. Alright, and these will cancel. 4y minus 4y is 0. 5x and 12x is 17x. 17x equals 56. Divide by 17. Is that going to break down evenly? I don't think it is. 56 divided by 7. Let's see. 3 times 7, 4 times 7, 5 times 7, 6 times 7, 7 times 7. No. It's not going to break down evenly. So maybe I don't want to do 4. Oh, well, I made a mistake. That's why. I wrote 56, but I didn't add the 12. 56 and 12 is 68. That makes a lot more sense. And this divided by this is 7 times 6 is 48. So I wonder if it comes down to 4. 17 times 4, 8, 2, 68. It does come down to 4. Alright, so x equals 4. And I can put it into any of the equations, whatever one looks the easiest. Let's do the first one again. 3 times 4 minus y equals 14. 12 minus y equals 14. Subtract 12 from both sides. Negative y equals 2. Divide by negative 1 to get rid of the negative sign. Right? Y equals negative 2. So, our solution to this system of equations, my x value is 4, my y value is negative 2. That's where the lines are going to cross. Have it. Alright, scrolling down to 5. Again, I can multiply the x values, the coefficients, and make that 6 and negative 6. But to be honest, all I have to do is multiply this one of them by positive 3. I just have to multiply this one by positive 3 to make it opposite, right? Because it's already... Alright, so that would be 6x minus 3y equals negative 15. Be careful when you're distributing to think about your negative signs. Alright, think about your negative signs. Alright, so now we have 3x oh, wait a minute. I want this to be positive. So I need this to be negative. So let's do negative 3. That gives me negative 6x plus 3y, there we go, equals positive 15. I hope you're doing this in pencil because math is all about making mistakes and learning from the mistakes. Alright, 3x minus 6x is negative 3x. The 3y's cancel. And I'm left with 15 minus 3, which is 12. Right? Negative 3 plus 15, right, is the same as 15 minus 3. 12. Rearrange the numbers in your head until they make sense. Divide by negative 3. X equals negative 4. Alright, so if x is negative 4 here, it's going to give me a negative 12 minus 3y. If x is negative 4 here, it's going to give me negative 8 minus y equals 5. If x is... So it doesn't matter which one you do. They're all going to be about the same. I don't feel like one is going to be easier, so I'm just going to do the first one. So 3x minus 3y equals negative 3. Negative 12 minus 3y equals negative 3. And we already have the x, so we're solving for the y. So add 12 to both sides, negative 3y. Remember, negative 3 plus 12 is the same as 12 minus 3, which is 9. Divide both sides by negative 3. Y equals negative 3. 9 divided by 3 is 3. So my solution is negative 4 for the x value, negative 3 for the y value. Alright, listen, if you've got it, you don't have to wait for me. Move ahead of me. Use the video to check your work. Right? Use the video to check your work instead of do the work for you. If you don't got it, keep watching. Right? I'm going to do the odds. When you're done, go back and do the evens. And then I've reinstated the quizzes, the self-check. So go on quizzes, check your answers for your even ones. Make sure you do them first so that you'll have your answer when quizzes pops up. And if you get it wrong, do it again and again and again and again until you get them all right. Only when you get them all right are you ready for the mastery check. And it's important to get it right on the first mastery check so you don't have to do extra work. I'm trying to save you work. Alright? The greatest multiple here is 21, so I could use that. But the greatest multiple here is 8, which means I only have to change one equation. So I want this to be negative 8, so I need to multiply it by negative 2. Because negative 2 times positive 4 will give me the negative 8. Alright, so now we have negative 6x minus 8y equals negative 12. Right? 7x minus 6x is x. Cancels. Negative 2. Now that I know x is negative 2, I can put it into any equation. Most of the time, the first equation is honestly the easiest one. But as you start working on it and start looking at it and start noticing patterns, you will quickly be able to notice which one's going to be the easier one. Right? 6x plus 4y equals 6. Add 6 to both sides. 4y equals 12. Divide by 4 on both sides. Y equals 3. So, for the x value of our solution, negative 2. For the y value, 3. That's our solution. number 9. Let's see, we have 5 and 7, and we have 9 and 10. The greatest common factor, or the greatest common multiple of 9 and 10 is 90. That is a very large number. I don't want to deal with a 90. The greatest common multiple between 5 and 7 is 35. It's still a big number, but it's way less than 90. So we're going to make them both 35. One needs to be a positive 35 and one needs to be a negative 35. To make 5 a positive 35, we're going to multiply it times 7. To make 7 a negative 35, we're going to multiply it by negative 5. We're going to end up with 2 equivalent equations. Alright, so the first one is 35x, because 7 times 5 is 35. 7 times 9 is 63, so plus 63y. And then 7 times negative 10 is negative 70. Right? And then our next equation, negative 35x, which is why we did that. We have negative 50y. Right? Negative 35, negative 50. And positive 5 equals positive 5. Alright. These cancel each other out. 63 minus 50 is 13y. 70, negative 70 plus 5. That means we're going closer to 0. So we're moving down the number line. Right? So technically we're moving to the right on the number line because we're adding 5. So this number is going to get lower because it's negative. So it's going to be negative 65. And I think that would be 5. 65 divided by 13. How did I know that? I needed a number that would times by 3 to give me a 5, and that would be 5, because 5 times 3 is 15. So 5 times 13 would give me 65. So my y is negative 5. Now that I know my y, I can use either of those numbers. I'm going to use the first equation. I was telling the truth when I said that most of the time the first equation is the easiest. Not always, but most of the time. Alright, 5x minus 45 equals negative 10. Add 45 to both. Add 45 to both sides. Right, and this is 45 minus 10, which is 35. So we have 5x equals 35. Divide by 5. X equals 7. So, remember, x comes first in the solution. Coordinate. The x always comes first. 7, negative 5 is our solution to that system of equations. Alright, last one, and then it's all you. Alright, 11. Alright, so common multiple would be 6. Oh, be careful, they're not in the same order. Remember, the directions said they have to line them up. So whatever we do in the end, we have to line them up. You can't cancel them if they're not lined up. So the first thing I'm going to do before I even touch this is rearrange it. Right? So I'm keeping the first equation just as it is. 2x plus 4y equals 6. And then to make my negative 6y disappear and move back to this side so it can line up, I'm going to add 6y. Right? So that's going to give me 3x plus 6y equals 12. Alright, now they're lined up. Now I can look at them. I knew they weren't lined up because the equal signs were in a different place. They tried to trick us. Don't let them trick you. Alright, Now I need a common but opposite coefficient. Let's make this one 6, so I'm going to multiply it times 3, and let's make this one negative 6, so I'm going to multiply it by negative 2. Alright, so now we have 6x plus 12y equals 18 minus 6x minus 12y equals negative 24. Oh, this is interesting. Right? 6x minus 6x is 0. 12y minus 12y is 0. 18 minus 24 is negative 6. 0 equals negative 6. That's just not true. That's just not true. That's not possible. This is a zero solution. There is no place where those two lines are going to cross. There just isn't. If you rearrange them into slope-intercept form, you would notice they have the same slope, which means they're parallel, which means they have no solution. They will never cross. They're parallel. Nice. Okay? Good luck.